Have you ever wondered how we can actually trace the image of an object for a concave mirror? It's always tricky because we never know where to actually do our lines to make sure things happen. So in this video, I'm going to share with you how we can trace rays of light for to localize an image from an object in a plane mirror. And then I'm going to show you how we can use what we know from the plane mirror to find where the images are for concave mirrors. So that is the plan for us. So the first thing we're going to talk about is how we get from a plane mirror to a concave mirror. So here's an example of a disco ball. These are made of plane mirrors. If you get close, you can see it is a ball because each of the small plane mirrors are glued on this sphere. So if you were to take a plane mirror, how can we find the image from an object? So I'm going to do a quick example and then we're going to lead into concave mirrors. So here is a plane mirror. And if I have, for example, a tree like this, and we have an object, we can figure out where the image is. The image will always be behind the mirror. For example, if you go in the washroom in your house and you go in front of a mirror, you know who you are and you know your image is behind the mirror. And we know that because we can see it. But how does the light rays work on that? Something that is easy is the fact that you can always do straight lines like this. And you know that if we have this distance here, we have the same distance like this, and like this. And this is like this, and then, okay, let's see if I can do a better drawing than that. So we have this point here, this point there, and this point here. So we have this. Perfect. So just the distance from the mirror will be able to tell us where the image is. We know that because we can see in the mirror. Something else you would have learned in your science class is that if you take a ray of light, and we have what we call an imaginary line that we call the normal that is on this flat mirror. So that means that if I have a ray of light that goes like this, from this point right here, we have a normal that is like that. We also know that the reflection will be going this way. If you think, very nice. The ray will go up this way, and if you were to extend it at the back, you could see that we have this purple line linking and crossing this point right here. For the same reason that you have here two lines crossing, we have two lines crossing there. It is another way to know that, yes, we have the image at this place. In order to do this, some of you says, well, I forget how it works. Let's see if we can look at the basic theory of a plane mirror. If you have a plane mirror like this, can we see it nicely? Very nice. And you have the normal like that. If you have a ray of light going this way to this point, so here we have the ray of incidence, or is it the ray of the incidence or the incident ray? As you can see, my first language is French, and I'm always working with some ideas. So it's called incident ray. So this is the incident ray, and we know that it will have here a reflected ray. And something that is interesting is the fact that we have two angles to keep in mind. We have this angle here, which is called the angle of incidence, So the angle between the normal and the incident ray. So this is the angle of incidence here of incidence like this. We also have the angle of reflection. We have a little r like this, which is the angle of reflection. And interestingly enough, in the laws of reflection, the angle of incidence equal the angle of reflection. So that means that when I had this ray here going to the normal, we had two angles, the angle of incidence and the angle of reflection. All of these all work together. If you want more information about how this works, I'm going to put here a link with a video I recorded last week about this theory right here. So this is a review of plane mirror. But what happens when you go from plane mirror to a concave mirror? And that's what is interesting, and that's what we're going to see right now. So let's see. Like this. So if I draw a plane mirror, so we have, oh, there you go. I'm going to use this one right here. If you have a plane mirror, you have here an imaginary normal, but that means that you also have as many normal imaginary lines here, which are all at 90 degrees, and they're all parallel to each other. Why is it important? Is that if I have other rays, so a ray going this way to this point, it will be reflected here. If I take another color and then go here, it will go there, and then go here, it will go there. You could see that all the angles that are parallel here will be reflected parallel on the other side. So that's something to keep in mind. Now, the next thing I want to show is the following. So let's see if I can. I had a ruler. Oh, look at this. I'm going to take a book. I think that's a great idea. So if you have a book like this and you think of it as a plane mirror, you would have normals that are all parallel to each other but perpendicular to this surface. But if I take this book and I curve it like this, you could see that all the normals that will be on a plane mirror somehow would have to change direction. And that's the drawing I'm going to do for you right now. So if I have a mirror that looks like this, and you think of the normals we have here, the normal will be perpendicular to the mirror. However, if the mirror changes, it's in curvature, like this, like this, like this. That means that now we have normals that used to be parallel and perpendicular. Now they all seem to be going in one specific point. These normals are still perpendicular. However, the way they point is different. And that is kind of exciting. So here, the next thing we're going to do is how we draw a bicycle wheel. So you probably know with me that if you have a bicycle, you have a wheel like this. In the side, you have the center, and you have the spokes that are going all around like this. And you know that each of these will all be perpendicular to the outside of the wheel. And you have a center right there. Each of these lines would be the same length, and therefore the radius of your wheel. Here with the mirror, we did the same thing. If you were to take these and you were to extend them, oops. So one reason I like to do the drawing is sometimes we see images on a textbook. However, we don't always know where the lines are coming from. So So here it seems that all of these normal will all point to a center. We call this point C for center of curvature. C, center of curvature, like this. Now, when we do optics, we also like to have an axis that goes right in the middle here of our mirror, and we call that our principal axis. So here we are building the vocabulary to better understand how concave mirrors work and also how to trace their image. Perfect. Now, something that is interesting is that if we have the center of curvature here, there's another point that is called the focal point. The focal point is right here, and we call it F. F is the focal point, like this. Okay, so how can we better define this point right here? So let's see. You know as well as me that if I had a ray that was along the principal axis, we'll get here to the mirror, we'll be going back straight where it came from along the same principal axis, because we have here the normal and we have the angle of incidence and the angle of reflection to be 0. The next question that is interesting is if we have a line that goes like this, that is parallel to the principal axis, we do know that we have an angle of incidence like this, but we also know that we will have an angle of reflection like that. So if we had a plane mirror, let's say I was hiding everything and this was just a small plane mirror, this part here is exactly the same thing we had earlier. But what is interesting is that this line here would be reflected and would go through the focal point here. Okay, so let's see if I can do a few more of these lines. If I have here a line that goes like this, that is also parallel to the principal axis, I have here the angle of incidence, we have here the angle of reflection, we have this ray that would be going this way. For the same way, if we have lines on the southern part of the principal axis, let's see what we get. If we have here a line that is like this towards the mirror, we have here the angle of incidence, and we have here the angle of reflection. Both of them are the same, and we have our ray of light going through the focal point here. So this will be the end of this first video about reflection on concave mirror. What I have here is that all the rays of light that are parallel to the principal axis will always be reflected at the focal point. Other piece of interest as well, if you have 2 times the distance of the focal point, that is the same thing as the distance for the center of curvature. That means that these 2 points here, you can divide in 2. So the length here and the length here will be actually the same. So this is how concave mirror works. Let's see if I can give you another example before we conclude this video. So this one will go a bit faster so that when you are in a situation where you have a test or you have to give an example, you can understand where the rays are going. So here I have my center of curvature. If I put my elbow here, this is my concave mirror with the center of curvature. You could see here that my forearm is actually the radius of this concave mirror. Here I have my principal axis that is going through. We have this point here, and right in the middle, I have my focal point. Now, interestingly enough, if I have a ray that is parallel to my principal axis, this one will be going through the focal point. So if you go back a few minutes, I explained all to you what the normal here is. Right there, we have the angle of incidence, angle of reflection. But if you forget all the theory, this is how simplified version is. We have the ray of the incident ray here, reflected ray here. We don't need to worry about what's going on here, but we know that the ray would have to go through the focal point, and we explained that already. If I have a ray that is like this, parallel to the principal axis, it will be going through the focal point like this. Perfect. Now, another thing that is interesting, if it happened that someone says, okay, what if I have a ray that is going through the focal point? So you could see here, if I have a ray parallel to principal axis, it will go through the focal point. But the same thing will be true if I have a ray going through the focal point, the reflection would be parallel to the principal axis. So if I have here a ray that is going through the focal point, here the reflection would be parallel to the principal axis. And that's how we can trace rays of light with a concave mirror. So let's see if we can, in the next video, figuring out how we can find where the images are. So in this, I'm going to put here a link on more theory about the laws of reflection with plane mirror, and you're going to see it right there.